Hello everyone, welcome to Scholar Lab. Our simulations can transform your teaching approach, making lessons much more interactive and captivating for your students. Scholar Lab is a distinctive virtual laboratory that brings intricate STEM concepts to life through engaging simulations. This tool is crafted to aid students in comprehending and applying scientific principles in practical situations. Welcome to an exciting simulation where you will dive into the various separation techniques that are essential in both chemistry labs and real world applications. From separating solids from liquids to distinguishing different kinds of liquid from the mixture, you will explore the techniques like simple distillation, fractional distillation, centrifugation, and chromatography. Let me open separation processes simulation for you. Each simulation begins with a game plan. This outlines the overall objective of the simulation. If you are a new user, kindly go through this section thoroughly to maximize your experience. Here we have 5 important parts. The first one is simple distillation. Let's get into it. We'll begin by selecting the mixture of acetone plus water or the solution B, that is water plus salt. Let's select acetone plus water mixture. By clicking on it, it will automatically add it to the round bottom flask placed on a Bunsen burner. It's time to add the thermometer to measure the temperature of the solution being boiled. I'm turning on the burner. By using this burner level slider on the right hand side of your screen, you can change the burner level from low to high. As you can see on the board, the temperature is getting increased. As we all know, water is having the boiling point of 100 and acetone is having less boiling point than water. So acetone get evaporated first and it will go through this condenser and we'll get separate acetone in the conical flask. This simple distillation process makes use of the boiling point difference between the two liquids to separate them from the mixture. Let's go to the second solution, that is salt plus water. For that, I'm going to click that reset button. Now we have this solution B, salt plus water. We all know that salt plus water is a mixture of solid in liquid. Let's see how it does in simple distillation method. Upon turning on the Bunsen burner, you can see this temperature is increasing, which is shown on the board. Once the water reaches its boiling point, it evaporates and goes through this condenser. Condenser helps the vapors to cool down, then it is collected in the liquid form in the conical flask. Once we collected all water particles from the mixture, the solid, that is salt, is remained in the down bottom flask. As you can see, the white particle remains in the round bottom flask. This method is effective method for purifying water or extracting one component from the mixture. Let's move on to the second part of the simulation, that is chromatography. Here we are going to mark that in the paper, and we are going to immerse the paper into the solution. This method is particularly used for the colored substances. Once we place a part of the sample on the chromatography paper, I have suspended it in the solution. The solution can be of solvent, that is water or ethanol. The solvent moves up the paper by capillary action, carrying the different components of mixture at different rates based on their solubility and affinity to the paper. As a solvent moves, the different components of the mixture separate into distant spots on the paper. For example, black ink which we have put may separate into different colors, revealing its constituent dyes. You can click on this fast forward button to make the process faster. Once the process is done, you can zoom in and view the readings. This table helps us to give the readings what we have observed through this chromatography method. The first component in the table is how much the solvent has traveled by. This colorless part marks the solvent, that is around 9.5. The purple one is up to 1.4. The orange one once you have given the input, you can click on submit button. Upon clicking on submit button, it will give you the values which are correct. You can calculate the RF value by using the formula on the board. The distance moved by the component divided by the distance moved by the solvent. Once you have submitted the RF value, it will give you the correct answers of that RF value. Chromatography is an excellent technique for separating the mixtures based on their solubility and molecular interactions. It is widely used in chemical analysis, including testing food dyes and separating plant pigments. Let's move on to the third part of the simulation, that is centrifugation. Here we are using a mechanical centrifuge. Here we have two solutions, muddy water and milk is mixed with water and fatty acids. Let me add these two solutions to the machine. Now it's time to power on the machine. You can adjust the centripetal force or speed using the slider on the right. Once the process is done, you can clearly see that the cream is separated from the milk and the remaining are the skimmed milk. Similarly, from the muddy water, mud gets separated from the water. It is a fast and efficient way to separate solids from liquids, especially when the particles are too fine to be separated by filtration. It is commonly used in dairy processing and medicinal laboratories. Let's move on to the fourth part of the simulation, that is fractional distillation. Fractional distillation allows you to separate liquids with similar boiling points. Here we have the crude oil, which will be passed through the furnace, which is having very high temperature. By clicking on it, you can see what is inside the furnace and these drakes or furnace. You can start by entering the boiling points of refinery gas, petrol, naphtha, kerosene, diesel, oils. Or else you can click on skip to play to start the process. Here we have the boiling points arranged in the increasing order, and I'm turning on the furnace and passing the crude oil through it. The top layer from where we can get the boiling point which are very lower among these. Fractional distillation is essential to separating liquids with close boiling points. It's widely used in industries like petroleum refining, where the multiple components need to be separated from crude oil. Like this. The last part of the simulation is quiz. Quiz will give you the analysis of how much students have understood the concept. And the last part of the simulation is quiz, which will give you the analysis of students how understand the concept. Here we have set of 5 questions and all 5 questions must be answered to check the scores. Overall, by experimenting each of these processes, your students will understand how these separation techniques are applied in real-world scenarios and scientific research. Happy learning! Thanks for watching.